Hello guys, I'm back. Today let me talk to you about the relationship between the pipe instrumentation diagram and also the isometrics. My name is Jeferson Costa and I teach students, graduates and engineers how to work with chemical process engineering and plant design. Follow my profile and like this video to have access to hundreds of videos and content related to chemical process engineering and plant design. So when we start a project as a chemical process engineer, one of the first documents that we produce in plant design is the piping and instrumentation diagram once we finish the heating material balance and the process flow diagram. And in the work process of plant design, the piping instrumentation diagram is used as the source for the production or for the development of the isometrics. So I have seen some posts doing the relation or the listing the differences between the pipe instrumentation diagram and the isometrics, but in my point of view, this is not possible to do because they are completely different documents. So why I have the pipe instrumentation diagram is to show the process, to show the pipes, to show the controls, and to let a multidisciplinary team work on that to build plant design. Why I have the isometrics? Isometrics is a documentation done by the piping engineering discipline that is used to only with the purpose for adding all the piping features and controls that is installed in the pipelines or in the pipes. So the main objective of the isometrics is to have the route, the specific route of a pipeline, and also the list of materials to be built, or the BOM, billing of materials, that will be used by the procurement to purchase all the fittings that are needed to install the pipelines, and with that sent to the field for the construction and after commissioning, startup, and etc. So once we finish the pipe instrumentation diagram as a chemical process engineer and the piping engineer gets the pipe instrumentation diagram to build the isometrics, many of the cases we don't review the isometrics to perform pressure drop calculations for your project, for instance, unless that the pressure drop calculations for the design is a critical information or a critical point of your process. When we are performing the heating material balance calculations, we have a safety margin that will allow the configuration of the road of the isometrics. And any important information like it's not allowed to have low points, or if we need to add some kind of specific instrumentation or fittings to the pipelines, we will add that information in the pipe instrumentation diagram. So when we start a greenfield project, a project from the scratch, the sequence is do the heating material balance, perform the process flow diagram, and after that develop the pipe instrumentation diagram. And with the pipe instrumentation diagram, the pipe engineering department will build the isometrics. However, if you are doing a brownfield project, a revamping, a debottlenecking of a plant, and you need to use the existing facility to improve the performance of the plant, you will get the isometrics already done in the previous project, and you will verify if the increase in flow, the increase in pressure, or the change in temperature can impact in some ways or can be limited by the existing pipelines that is available. For instance, you need to increase the plant capacity in a debottlenecking in 30%, and when you verify the pressure drop calculations in the existing pipeline, you verify that it's not able to achieve the new conditions with the existing pipeline. So eventually you will need to propose the change in the diameter of the pipe. So during the erection of this revamping, eventually you will have modifications in the existing facility. So In many cases, we'll only deal with the isometrics as a chemical process engineer working with plant design when we need to do a debottlenecking and use the existing facility to verify if the performance of the plant is achievable or not with the existing facility, or if during operations, once you finish the startup and commissioning of the plant, you verify that you have too much pressure drop or you are not getting the performance of the plant. So with the as-built P&Id and the isometrics, you will verify, you will do a double check in the pressure drop calculations. Again, if the pressure drop calculations is a critical point in your project, eventually once the isometrics are done, you will get in touch with them just to do a check in your calculations. This is it, guys. I hope you like it, and I'll see you soon in the next video. Bye bye.